Hello and welcome. I hope you can hear me. Welcome to the next Improbable Matter live stream. My name is Val. I run the Improbable Matter channel. Of course, this live stream will be here to discuss my previous video, which has made quite a number of mistakes. I want to clarify the mistakes. I want to clarify what I clearly didn't get across, some of my points. Let's just to set some sort of ground rules, as it were. So on the, I believe, was it the 10th of July or so, I put out a video called Why Object-Oriented Programming is Slow and a Stupid Idea to Fix It. That garnered quite a number of interesting responses, but I definitely want to address the factual mistakes there. So this was, by the way, the third or fourth sort of opinion-based video that I made. Usually, of course, I make kind of fairly factual stuff, things you'd find in a textbook, and I do encourage you to look in a textbook. This is the third or fourth opinion-based video. The first being the Helian one, then the AI one, and then this. I guess you could count my video that probably none of you have seen about the comedy phone shop, since comedies are intrinsically sort of subjective. That was also opinion-based. So I'm here to clarify that, and just to kind of set things up. I will sort of mostly do this through the lens of comments that were left. I typically will anonymize comments, whether positive or negative, so I will scrub usernames and pictures. That's not to sort of denigrate the person that left the comment, but they didn't consent to be in a video. They didn't consent necessarily, so I blank out usernames. But if you want credit for a particularly insightful comment or a zinger that you left, leave another comment under this video. So yeah, that's that. What did I want to say? So the first thing to say is that this comment probably sums up the video I made better than I did, clearly. So the point I was trying to make, as it says here, that OOP does have benefits, but these benefits, the structure that it adds to the code, adds inefficiencies. And so maybe the IDE should enforce those things instead of having the code be laden with them, and that sort of thing. So this is, as I say, this comment clearly summed up what I was trying to say better than myself. So thank you for that. Now, I got this comment, which is quite long, and I'll come back to the kind of very general bits at the at the beginning of the comment, but the end here actually is quite correct. The end here says, effectively, that what I tried to do was I tried to fix a problem that users of OOP just don't have. They're perfectly fine, and that's 100% correct. And so actually, this has kind of made me realize a profound point. I think what would have been better is to approach what I did from exactly the opposite direction. So I said, how can we maybe make OOP code more performant? And lots of people said, well, we don't really need to. It's performant enough. We don't want to sort of hobble our nicely laid out code for the sake of a little bit of performance. But let's flip that on its head. What about, right? So I personally do need to write a lot of performant code. Well, I'll mention that a bit more later on in the video, or in this live stream specifically. But so, okay, I need to write performant code quite often, physics simulations, that sort of thing. And when I do, I sort of have to decide, okay, well, how am I going to do this? And I look at OOP And I think, well, that's nice. It'd be nice to have a class to encapsulate things. It'd be nice to have this and that. But then I think, if there's going to be a performance hit, I really need to squeeze out every sort of percentage point of performance. So then I end up not using OOP. Right? And people will say, other comments later will say, choose the right tool for the right job, which is exactly what I'm doing. I'm choosing not to use OOP because it's not the right tool for my job. But what if we approach what I tried to say from this direction? Maybe we could make OOP a better tool, and then, people that do really care about performance would find it more useful, and then it would be the appropriate tool for them, for people like me. And if we do that, then maybe we'll make it easier for the people that already perfectly well use OOP, which again, as I stated, is the majority probably of coders, or a good plurality, if not the majority. It'll make it easier for them to then optimize their code if they so wish, if it becomes important. So that's a very fair point. So one thing that I'd like to, if I can actually figure out the mechanics here on YouTube, is perhaps a better title originally would have been, instead of what I called it, to call it Why I Don't Use OOP and a Stupid Idea to Fix That. So that's my suggestion. Now, I don't know how many viewers I actually have. 10 viewers. I don't know if I can make a poll here easily. Right, let's start a poll. Here we go. So would you be happy for me to retroactively change the original video's title? I don't normally do that. For those that wish my kind of hubris to be recorded, it still will be recorded in this video. But I will give viewers a chance to vote on this. There you go. Start poll. I don't know if that'll actually work. Okay, we got one vote, 100%. So that's not me, by the way. So that's effectively 2 votes, since obviously I started it. 2 votes for 100%. Okay, fantastic. So we'll change it. Why I Don't Use OOP. I think that's a much fairer title. And I think a lot of the kind of jimmies that I rustled, as it were, a lot of the offense that people quite rightly took, that would probably fix. And so we're approaching this now from the opposite perspective, which is how can we make OOP more relevant for people that do want to have performance, but maybe they'd like to have the nice kind of organizational points of OOP. Okay. I also hope, can someone maybe say in chat, can you actually hear me well? Is the audio coming through well or not? Maybe get some chat responses here. Anyway, while we do that, what else did I want to say? Okay, so if nothing else, I'll get to, correcting things in a moment, but what I wanted to do was kind of, at least to start with, if nothing else, then to get across the points that I tried to get across, but it seems, sort of people were misled, which, if it was 1 or 2 people, then that's their fault, but if it's a majority, if it's a majority of the listeners that kind of didn't get what I said, it's my fault for not explaining things properly. That's how I see it. So let me kind of just very quickly go through what my main points were for my actual idea I put forward. And I've also kind of pruned this. So thank you for the comments, feedback. Lots of people fed back. Let me go through a pruned version. So point 0, we'll get back to in a moment. Point 1, this is what I wanted, what I'd like to put forward. We have an IDE. It's somehow becomes split down the middle. That's, we'll leave the exact UI, we can discuss that later. But let's say for the moment it gets split down the middle. And on the left, you have high-level code. using, for example, objects, etc. And on the right, what you have is you have placed in some sort of rich annotation for the code. Now this is not an afterthought. The exact kind of style, display and placement and all those things are actually then enforced. So when you produce a code, right, this will actually be kind of somehow enforced as part of that. Whatever you produce as documentation there will be, the IDE will kind of bind that to the main code. It's the same way as comments, right? Comments are intrinsically part of any code you write. You can, of course, write code without any comments whatsoever. And I was going to joke, I should know, that is a joke. But the comments are a part of the code. Here, this enforces that some kind of, rich, as I might put it, documentation with videos, images, etc., is then kind of anchored correctly where the original programmer anchored it and so on. Point one. Okay, we'll discuss that more later. Point two. You now have a little UI feature like a little plus sign or something like that. And when you click it, this is completely optional. First of all, of course, you can write your high-level code, compile it, run it, etc. You have a, part by part, the little, UI feature where you can expand a section of the code. And what it will show is it will show high-level code that's effectively, it is transpiled into some lower-level code to help the programmer kind of diagnose, have a look. And almost in real time, maybe not exactly in real time, as you change the your actual high-level code, it'll propagate changes through to the low level. That's, again, that's nothing particularly new, but you're integrating it now into the IDE, even better. And another point, thanks to Alex for emailing this in, I was actually thinking a lot about this, and one other good thing you could have is you could then write benchmarks, or like micro benchmarks, little unit tests, to actually test the performance. Remember, we're talking about performance here. You would write little benchmarks, and again, they will then be saved as sort of, intrinsically part of that code, not part of the actual, production code, but part of the whole package that you're sending out. And so you write a little micro benchmark. You change the you change your actual production code on the left. Press a little button. It runs the benchmark. Tells you how long it takes. Oh, again, just to confirm, all of this is optional. I did mention things like AI at this level, at this point. This is entirely kind of deterministic, as it were. The IDE is just doing this. Again, nothing particularly new. People have been writing benchmarks and so on since coding began, probably, but we're saying that this is now in the IDE, and that benchmark, again, of course, you can have, and you do have, unit tests that are saved, but this is kind of really intrinsic, really right there at hand for someone to do. That would certainly be useful for me. I'm writing a function. I may want to actually optimize it somewhat. If I write in the IDE had all these features, I think it would make it faster for me. But we can talk about that more later. Again, though, just to stress, this is completely optional. So you wouldn't probably do this kind of approach to all of your code. Maybe not even 10% of your code. Maybe less than 10%. That's fine. But it's, again, of course, you pick the 10% that actually needs that performance. The part that doesn't, you don't have to. People seem to have gotten the idea that I meant that in the first video that I made, that it would change the code completely. No, you can do this kind of bit by bit. You can just target the specific bottlenecks in your code. Fine. Point 3 then, and this is now more kind of speculative. Maybe it just won't work. but I think there's room here, which is that now the programmer, because you see the mapping between the kind of high-level code and the low-level code is, of course, intrinsically not a one-to-one mapping. Okay, that's why an optimizer can work, right? Because if high-level code uniquely specified every single machine instruction, then it would be pointless. The high-level code would effectively just be a wrapper for low-level code. But obviously, there's wiggle room, and so because of that wiggle room, maybe now the programmer can modify the stuff in the right hand side to tweak and modify exactly the lower level. Maybe it's an intermediate representation, maybe some assembly directly, that sort of thing. But here's the important point. And maybe, so that there may be, at least I initially saw it as a kind of hard changes. So like the programmer goes in and swaps the order of two assembly instructions. And maybe now, again, people have said, well, don't bother, you're never going to be better than a compiler. Maybe that's true. Maybe then a kind of more soft approach, this is what people have said and fed back, is maybe you just put in some kind of micro flags, and apparently there are. Again, I think Halide was mentioned, where basically, that kind of can be done via compiler flags. Fine, again, either or, but you're basically changing the lower level. But here's the thing, it's then enforced, and I guess, again, this is a point that people didn't seem to understand. It is then enforced, whatever changes you make on the right, quote unquote, on the right in the lower level code, have to be kind of consistent with the higher level code you have. And the IDE enforces that there is some standard that ensures that you can't change the actual high level meaning of the code without but by doing this low level stuff. Yes, as someone's just asked, will this stay up on YouTube? This will be up on YouTube. Yes, this will remain as a permanently on YouTube. As I say, if that's a question regarding the changing the video title, yes, my hubris will be recorded, at least in this video, even if I change the title just so that I don't kind of annoy people. Okay, but anyway, back to this. So yeah, so the point there is that, and this is strict, that you can't break the high level code by making these micro changes, however you make them. You may, there may be, this is a kind of pseudo directive that you say, don't actually do the packing, which is, something I discussed. So that's part of the point, and the IDE will rigorously enforce this. There may need to be a standard created, and maybe that's untenable. Maybe it's too much work, or just simply impossible to have a standard that will enforce that changes to the low-level code don't change the high-level code. Then it's pointless, of course. But and the next point, even more speculatively, right? What you can then do is, again, the IDE is enforcing that the low-level changes can't change the high-level code. Now, there's maybe an option or something like that that allows you to begin to actually, by making micro changes in the low-level or intermediate-level code, higher-level changes are at least suggested, if not implemented. This is where maybe AI would come in, but again, it would be strictly trying to interpret what the user's doing. Everything is still bound to a kind of standard. So of course, everything is enforced by rigorous standards, but it may be that you, by looking at the low level code, it may be that you now get the idea of breaking up classes or structs, or rearranging classes, merging them, whatever. That might, again, work. But this is the most speculative. And finally, the kind of highest level point that I wanted to make is, can we move some responsibility from the language up to a kind of more higher meta level ecosystem, whatever you may want to call it. Maybe not, but maybe you can. Okay, those were the kind of points. So I just want to run through them quickly just so that we are clear, because again, a lot of people were misled. Okay, back to point zero. Point zero that I tried to make, but obviously failed, is that high-level abstractions like OOP, not necessarily entirely OOP, can be other things, but high-level abstractions can cause performance overhead, and we may want to optimize these out. Can and may there, doing a lot of lifting. Of course, abstractions won't always cause a performance hit. They may be just as good, and the performance hit may not be noticeable, or we may not care. That's fine. So that was kind of a point that I wanted to make, but clearly did not make it well enough. But the real problem was that I'm an idiot, and of course, compilers will, in fact, automatically inline getter functions for a start, as pointed out in this and many other comments. Fair enough. There's a classic, the sort of classic Pam Beasley meme, or Pam Halpert meme, of corporate wants you to spot the difference between these two lines of code. Well, actually, they are the same. It's true. I was being very silly, very stupid, and the getters get in line, so that's not a problem. And the problem, the problem from the point of a video is that a major mistake, but at the start, is going to ruin the whole video. It kind of reminded me, the reactions sort of reminded me of, if anyone watches Yahtzee, the guy that did zero punctuation and now does fully Ramblomatic, semi-Ramblomatic, and so on. He reviewed this game. I think it's called 12 Minutes, and he said, it was good game, but then there's a twist at the end, and the twist ruined the entire game up to the end of it. He said, quote, "If you get dragged into an alley by an angry chef and disemboweled with a broken bottle, your subsequent Yelp review probably isn't going to focus on the restaurant's lovely filet mignon." So, unfortunately, this huge mistake by me kind of derailed the whole video, and everyone sort of clearly just couldn't get past it, which is fair enough. That was a big mistake. Yes, compilers will automatically inline getter functions, but little but here. So this comment here talks about, so it's using an example of, let's say you have a fireball and it has a method called explode, and what you want to do is that method then needs to have kind of references to other things. It's in a game. It needs to have references to other objects in that game, right? So the fireball's method has to apply, it has to do damage, it has to do various things. And basically, so this comment kind of reminded me of actually one of the second actual reference that I made in the original video, which is to Brian Will's video called "Object-Oriented Programming is Bad," and just to kind of just to map what he said, one of the most important points I think that he made into this context. So what we're saying is, on the left, the way you would do this, the way you'd have this problem. So you have a fireball object. It needs to get information from a spellcaster object, and it needs to then mutate, so access the spellcaster's spell attribute or whatever, and then mutate the target, creature, zombie, whatever, mutate the creature's health attribute, let's say, or maybe do a few other things. So yes, notionally on the left, what you do is you would then code the fireball to use a getter with the wizard object, whatever it is, to just get the spellcasting level. Let's say you need that for the damage calculation. Fine, you get the spellcasting level. Again, obviously, compiler, as we've just seen, as I fully accept, the compiler will inline that simple getter, or certainly it will very quickly resolve it. The performance hit is minimal. And then once you've then calculated the damage or whatever, you then mutate the, say, zombie object here. In fact, can I write this? Yes, I can write on here. Oop, no. No, maybe I cannot. No. Here we go. Yep. So mutates the zombie object here. And that should be very efficient, and that's fine. But the point that Brian Will kind of made in his video is that if you actually fully follow the OOP kind of philosophy, then different objects should be encapsulated, and as part of that, they should not have a reference to each other. So you effectively should not be able to have, as part of encapsulation, you should not be able to have references like this. What instead you should have for every project, again, watch the video, obviously makes a much better case than I do, but the summary is that every project basically has to have objects in a kind of tree hierarchy where you have some, to quote Brian Will, God object at the top, and that has references then to kind of other objects, and then there may be some hierarchy. So this is not an inheritance hierarchy. The wizard is not inheriting the world or whatever. It's just that the wizard does not have a reference to the fireball, whereas only the world God object is allowed to have a reference to the wizard, the fireball, and the zombie. As I say, watch the Brian Will video because he makes this point very well. But the thing that he immediately says in his video, he says, "Oh, I don't really care about performance," but I do. So if you watch that video, watch it, but think about the performance implications of what he's saying. And because what will happen here now then is that, so now you have the world having references to everything. So the world now will have to do a lot of kind of getting, as it were, right? The world will have to get information from the fireball. It'll have to get information from the wizard, then get information from the zombie. And so, yes, each getter will be inlined away, but you are still doing more operations than, was necessary in the strictly simple approach. Now, you might say that, and Brian Will in the video also says, well, okay, no one really does this, the thing on the right, and is it really, it's not really that valuable. But, if you actually did follow OOP properly, I think that there would actually be a performance hit from, simply encapsulation, right? The getters themselves, yeah, fine. They won't be slowing down your code at all. But the fact that you're encapsulating, and if you follow it properly, you then have a lot of these kind of message passing up and down, which is inefficient. Maybe, again, and we'll talk about this in a bit, or I'll talk about this in a bit, that maybe that doesn't matter. Obviously, there are plenty of games with fireballs or whatever that work perfectly well. If it ain't fixed, if it ain't broke, don't fix it, right? But just as a strictly point, I think there is something there. But anyway, let's forget that. But certainly I made a mistake there by just not enabling the optimization flag. That's it. Okay, but then the other point that I did make was to do with packing and to do with kind of basically data layout, which, to be fair, is not cannot be optimized straightforwardly. If you write this kind of code, put as many flags as you like, but if the compiler compiles things faithfully, then whether or not you have packing, the fact that you have a struct, and a lot of people talked about this as an array of structs versus a struct of arrays problem. If you have that, then you will objectively be slower. So this thing up top here will be slower than this on the bottom, whether or not you have packing, whether or not each of these Bob objects takes up 8 or 5 bytes. It will be slower if, and this is of course a very simple example, but if you're kind of going through and if you're not sort of using X and Y here at the same time, if you just do a single pass or something like that and you only care about the X's, then it will be objectively slower to have it encapsulated in a struct. Now, we can talk about this all day. Is this really OOP? Can you solve this with OOP? Yeah, this is just one of the many comments that talks about a struct of arrays versus array of structs. There's no free lunch. That's also a very fair point, I guess, to all of this. There is no free lunch. If you have an organizational kind of benefit, it may have a performance hit, of course. There was a point, and I want to kind of, the point I just made about the kind of with the fireballs and stuff, I think is relevant here as well. So, here's a typical comment that said, quite rightly, you can create a class that has a structure of arrays. Fine, you can have a class where you just have there's a comment, is this a data-oriented design? Yes, absolutely. Yeah, DoD. I'll come on to an example of DoD in a moment. But so you absolutely can have a class where you just have, why don't we just have Alice have like, a pointer to X and a pointer to Y, and then the X is contiguous and the Y is contiguous, right? Well, I would argue, based on what we just said about the kind of philosophy of OOP, as it were. Maybe that doesn't really matter in practice, but I would argue for the exact same reason as what Brian Will said. If you're going to follow the OOP philosophy, as it were, properly, I think you must, in this case, Alice here is arbitrary, but if X and Y truly belong together, and let me get my notepad out here to give an example. If X and Y truly belong together, I think that the kind of the array of structs is the only acceptable way. So, for example, right, we talk about, and a lot of comments talked about that OOP is about having the same sort of structures in code as real world things. So, let's say we had class car, right? And in car we had, we had something like float, doesn't really matter, but like miles traveled. And then we had string, this may not be actual C code, but a string, registration number or license plate, whatever you want to call it. Plate, whatever it is, right? So if you want to model, and now we have like a million cars, right? So we have, car, all cars, or something like that, of which we have, a million in our database or whatever, or some bajillion, big number. I would argue that, if you want to represent what a real car is, each real car in the real world is a gestalt, a fully realized thing that has its own, odometer with the miles traveled and the registration plate. So if you really want to if you want to have your code be like real life, what you should have is like a bunch of cars. A car with all the data about the cars, and then next to it the next car with all the data about that car, and then the next car, and so on. So that is necessarily an array of structs, which then, now that may be very good, that may be exactly what you want from a performance point of view. It may be that you don't care, we'll come back to that again, but let's suppose that you do care about performance, and what you wanted to do was like process the miles traveled. You want to get some statistics, you want to do some, big fancy kind of models, whatever, about just the miles that the cars traveled. You don't care about the registration, and then the other, 15 different other class attributes, you don't care about those, you just care about miles traveled, then of course you'd want to have a struct of arrays. But I would argue that for the same reason that for the same kind of reason that you basically you encapsulate, and you should really just have a big God object and lots of other objects underneath, I'd argue for the same reason proper OOP would force you effectively to have an array of structs, and then that's not as efficient then as a comment pointed out, as a live comment pointed out, data-oriented design. So that's just a little maybe justification again. Well, this is actually not strictly wrong, but yeah, the getter thing was very embarrassing for me. Fair enough. And of course, yeah, and okay, fair enough. I'm totally willing to concede my wording was wrong. The fact that here one of the bobs is 8 bytes, that should be called padding, not slop. Slop is not even an unofficial name. So yes, the point of adding useless bytes to make a bob object 8 bytes rather than 5, which I very briefly mentioned, didn't go into, but there's so this is actually an example that I wrote because I wanted to illustrate something to some students I currently have, where I'm teaching them about cache coherence, what a direct mapped cache is, and so on. So like real hardware. This is a great example. Again, if you're a student, I'm sure all of you people in the comments who clearly have 30 years of experience, as you've said in programming, obviously know this like the back of your hand. But for any newer students, you pad it out so that it fits nicely in a inside a cache line. If you had so for example, the computer that I'm coming to you from has 64 bytes in a cache line. So if you had 13, but if you didn't pad and you had 13 bobs, the 13th, that would be 65 bytes, right? The 13th bob would sort of hang annoyingly over 2 cache lines, which would actually, in the long term, make certain things slower. Not if you're doing this kind of strided access, but it in ordinarily, that's why the compiler would put that in, so that then you just have 8 bobs neatly in a cache line, as opposed to as I say 12 and then parts of one. And that should be called padding. Fair enough. Completely correct. That is what that's called. Forget what I said. Okay. Right. Okay. So some suggestions that have been made. A lot of good suggestions. Great. First, the Rust. Fair enough. A lot of people brought up Rust. Great. Could be a very good solution to this. ECS is the other big one that lots of people brought up. Also good. So that allows you to basically reorganize how you have things in memory and what you need them for. Lots of people commented about how this would look in a video game. So what if you had each of your objects, which is, say, a character or something, you might only want to look at the coordinates as opposed to all the other attributes of your game character. And ECS was, as I understand it, created to solve that. So yeah, ECS would allow you to kind of do this efficiently, do all this SOA versus AOS stuff. A lot of other points here that I'll come back to as well. So this second comment here talks about performance is everything is the wrong mindset. I will come back to that. I do agree. It's got its place. So yeah, okay, fine. But what I wanted to talk about is give a much more realistic example, or kind of connected pair of examples. So here's a couple of talks by Tony Albrecht that you can find. There's the URLs there, and he actually talks about a realistic version of this. So he's talking about, graphics, right? He was on Riot Games or something, but so he's talking about making operations on objects which are, game graphical objects, that sort of thing. So it's a real example. This is now not a kind of toy that I just made up. By the way, okay, let me go back actually and just say, as you probably know, the examples I make for all my videos are stupid and simple. Okay, it's just, I guess, more people program than sort of care about plasma physics or whatever. But all my examples are stupid and very simplified. So don't start. The temptation people have, and they do that on the other videos, is to say, oh, it's this is too simple an example. You're clearly know nothing, but this is a deliberately simple example. It's not real life one. It's one for the purposes of a YouTube video. It's not it's not meant to be exhaustive. The same with all my other videos. For example, I did one about Fourier theory, right, or applications of Fourier theory. If you're at college, you probably know, you certainly know that the Fourier transform involves an integral. Well, guess what? I never used the word integral in a video about Fourier transforms, not because I don't know what an integral is, because it was to keep it simple. So this was to keep it simple. But there is a real example here where it is actually realistic. So it is a real life one as well. And the performance increase from fixing and optimizing this, kind of how you put things into cache as well. There's a lot of talks, as very good pair of talks with a lot of features there about things like the cache and taking a low-level look in order to improve performance. So it was in the first example there were like 11,000 3D objects. In the second example there were 44,000 or 55,000, something like that, or basically many more. And you're applying the same transform to each object. So what you want to do is you want to effectively, and I'm simplifying a lot here, but you want to effectively have a struct of arrays where you just have one array for all the objects, whatever it is, and just apply it. And so by being clever with looking at how the cache works, prefetching stuff into cache, that's pretty cool. There's actually a noticeable improvement now. It's in absolute terms it's milliseconds, but remember, of course, each of these it's rendered every frame, right? So if you're running at 60 FPS, a millisecond suddenly is not so trivial because you're doing it every 1/60 seconds, right? So and the point more there was it was a memory layout issue, right? And it was an issue that was not optimized by the compiler. Yes, everyone told me, oh, the compiler will optimize the compiler. Well, here there was a real example, and to quote from the second set of slides here, the compiler will not tidy your room. It isn't magic. It's not automatically going to optimize every single possible thing. Yes, I made a very embarrassing mistake to just have not run it with the optimization flag for the purpose of the video. Very stupid of me. But even if you did, there are certain things, including the example, the simple example that I had, but certainly real life examples which don't get optimized by the compiler. And the point was, as you can see from just the titles of the talk, the two versions of the talk, pitfalls of object-oriented programming. And the talks were in order to kind of advocate, introduce, discuss whatever DoD, data-oriented design type thing. And so the notion there was, again, you can just get it from the title of the talks, is that OOP practices, while they weren't a deal breaker completely, they weren't totally kind of deleterious, but if you just follow OOP without too much thought, you may get an inefficient result. And this is this is very kind of up in the air and very kind of speculative. But the points that I proposed, if you actually look in these talks, and the way that this gets solved, the way that, you know, the performance gets increased, or the way that the code gets analyzed, is by looking at a bunch of low-level stuff down to instructions and that sort of thing. So, you know, what's the, I don't quite know. Are you supposed to do an uwu face or something, or what is the right? My kind of very humble uwu, whatever it's called, suggestion is maybe if you had kind of some more of these IDE tools where you can instantly look at low-level the low-level in IR or whatever it is, low-level assembly, etc. Maybe this kind of problem could, in principle, get solved faster. Just a suggestion, you know. By having those kind of tools, by having things like by having micro benchmarks, for example, for certain functions, they're available to just quickly run through. You can quickly just iterate, change how your data is packed together, and you'll instantly, almost, you know, very quickly see right within the IDE, is this faster or is it actually worse? Okay, so real life example. So, you know, maybe not so dumb. It was a simple example for me, but this kind of thing does happen in kind of the real world, as it were. Okay, the next thing was that I didn't mention was inheritance and sort of what is it, the late binding kind of thing, where virtual functions, basically, lots of people commented about this. So I guess to carry on the previous analogy, you know, let's say we had a spell, we had a sort of parent class spell, a generic class for just any old magic spell in a game, and then you could have the spell be a fireball, you could have it be a frostbolt, you could have it be whatever. What you do is you'll process all the kind of the effects of all the spells using the method that's called do magic in this case, and in the original it's virtual, and so it gets, you know, the actual correct the correct version of that method effectively gets selected at runtime. As people have said, while they said that my original video sucked and my argument sucked, they wanted to point out that you know, it would be impossible here to optimize away and to make things in line. So, for example, you know, your fireball, let's say, all it does damage, but then your frostbolt does damage and slows the target, let's say. So because you don't know what the spell is going to be, you're committed to you know, do magic for a spell. So the do magic for the generic spell class, your compiler can't then inline this, and therefore you'll get, again, cache problems, because maybe the fireball has you know, affects a certain number of instructions, whereas the frostbolt doesn't. Anyway, I read this in a comment, and as we all know, YouTube comments must be correct. So this point must be correct, that virtual functions are slow. Fair enough. I didn't mention it in my original video, but yeah, that's also a downside. So I know there's a comment that this comment is wrong. That can't be. There's a live comment that this comment is wrong. No, I think that is correct, though. I should test it more thoroughly, though. As I say, it's on the internet, so it can't be wrong. But let's move on. A lot of the points that were raised were quite correct. You know, a lot of the points said, look, does this really matter in the real world, as it were? Not in, say, as I mentioned, something like a physics simulation, but in a real world application. Lots of people say this, and I totally agree that, firstly, lots of things like this kind of level of performance doesn't matter. You probably won't have 100 million of a particular object, really, in a real sort of scenario. You would in a big simulation, but that's its own thing. So this might just not matter at all, or be imperceptible. I did foresee this, and there were of course lots of comments saying I did foresee this. I did have a facetious comment to reply to this point, which was that something like, don't let Greta Thunberg hear you say that, because technically speaking, even if there is a let's say that a getter function, or the getter function is no worse, but let's say your data access pattern is slightly slower. That of course means more transistors switching, which means more fossil fuels being burnt. But of course, yeah, it's going to be a tiny proportion of what the fossil fuels are burned anyway. Fine. I grant that for many applications this doesn't matter. I also totally agree. Lots of people said, look, better to have something that works than something that's not finished, right? Get something out there, and you might just not have the money to optimize it. That doesn't mean that you shouldn't put out the software without a million little optimizations. Also, totally a fair point. Totally agree. I totally agree there. And finally, even if you do want to go and optimize, you should do that after you finish the whole project. But to be fair, the way I tried to get this across in the original video, the way hopefully I did get this across in the first part of this video, what I'm suggesting is, is totally coherent with this, because it then is a kind of afterthought or post-processing kind of thing, where you go through and you have this little UI feature where you just open up the particular bottlenecks that you have, and only after it actually works do you then begin optimizing. Totally agree with that as a concept. Totally, again, I follow that as well. First things first is you finish it to where it actually runs, then you start optimizing. You can have an idea of how you're going to optimize things ahead of time, of course. Lots of moving parts, but yeah, you absolutely totally agree with all these points. Lots and lots of comments, not just this one, have raised this, raised some permutation of these points. To be fair, to push back on that, sometimes, yes, it does matter in the so-called real world. Firstly, we just saw an example there from is it Tony Albrecht? From Tony Albrecht. Just want to get the name right. We did see an example where it matters in the so-called real world. Here's another commenter that says, it does matter to me. I guess typically games are probably the most relevant kind of high performance commercial application. Most people aren't buying commercial software to do a big climate model or anything like that, but games are probably the most kind of high performance thing that people are commercially buying, other than of course now various neural nets. So sometimes it does matter, and I just wanted to bring this up more because I love Paradox games than anything else. But I was playing around when the new year rolled around. I was playing Victoria 3, which is a great game, and just then patch 1.6 came out for that game, and that patch actually was there for the purposes of performance. So Victoria 3, for any fans or non-fans, is this kind of a big grand strategy simulation of the effectively the 19th century, so the Industrial Revolution. You play from 1836 to 1936. you have a world map with a bunch of like split up into a bunch of little provinces, and it tries to kind of simulate the Industrial Revolution, the economics, the politics, the population factors, and so on. And so the problem is, so like I've taken this from the 1.6 patch 1.6 devlog, where the map is split. You have, for example, Michigan is one of the let's say nodes, and the problem was that the performance really started to tank, because what happens is, okay, America is the land of opportunity, the land of the free, or whatever. So the game simulates how people immigrate to America, and then in other places you could make another country. You could make Oman the pillar of opportunity, if you so wish. But basically what happens is people migrate, and then for game mechanical reasons, it kind of has to track the nature of the people that migrate. So you have Michigan, and you'll have different sort of kind of ethnicities, I guess. So you have the Yankees, who are the main kind of social group in America, but then you'll have English and Irish and so on migrating to Michigan. And then the problem is that you have this, so the game keeps track of the kind of nationality, religion. So it'll keep track of like all the Protestant Germans that migrate to Michigan, all the Catholic Germans, all the say Ethiopian Nestorians or whoever. It keeps a track of that. Now each one of those is fine. Each one of those is just an int or something, or maybe a little more than that. But what happens is then you get these enormous data structures, because you'll have Michigan as a node, as probably an object or something in the game, and then it'll start getting these enormous kind of lists of these of all the possible nationalities that have moved to Michigan and all the jobs they do. Then it breaks it down, so it'll have all the originally German Catholic kind of lower class steel workers or something in Michigan, and it has to keep a track of all these. It's dynamic, so it's kind of probably spills over into different cache lines, that sort of thing. And so what happens, at patch 1.6 for Victoria 3 was intended to fix these performance issues that they had. So performance can be an issue, and obviously I don't know what the developers were doing, but I remember a lot of talk actually in the community was people were looking at like cache hits and cache misses when they were looking at the new patch. So here's a real world example, if you will, just because I love talking about Paradox games. But here's a real world example of where performance matters, and you do want to look at these kind of micro level features. How you have data mapped out and that sort of thing, how you're accessing the data. Do you have it all close together so you can get it neatly into cache and that sort of thing? And the point is that they changed actually how the game works, and all this, the things I just talked about. They changed how this like immigration mechanic works just to try and increase performance. And actually, apparently, the performance actually dipped initially. I can't remember how it is now, but so sometimes people do care about performance, even in a sort of commercial product. And so from my point of view, again, is looking at whether or not it's worth trying to improve the way performance, improve performance, have lots of tooling to improve performance. That's what I'm interested in. Can we make, in particular, OOP slightly better for performance? That's from my point of view. Some other points here. So yes, again, top comment talking about the fact that yes, I was wrong. Inlining makes some of my points moot. OOP is not good or bad. It just depends on how you use it. Of course, it is a tool. There are appropriate ways to use it and inappropriate ways. TypeScript came up a lot as well. So that's another potential thing to look at for myself and for yourself if you're interested. Fair enough. Thank you for pointing these things out. Now I want to kind of go into and expand on the kind of points that I made. So first of all, had some questions about how if you had, say, a wiki embedded inside an IDE, how that would work. It might be annoying having half the screen taken up. So maybe you just have a little button here that you press that kind of hides it, and then so you press this button and it kind of gets hidden. You then have an opposite button expanding. So there's a live comment, cache misses. So I'm actually, again, call me an idiot, but I am actually currently teaching a kind of hardware course. An expansion of my first ever video for my channel, of course, was how a computer works. So I'm teaching about, direct mapped versus associative caches or whatever. Yeah. And as I say, as I mentioned once again, this class here, I first wrote just to illustrate to my students why you might want to pad and make sure it gets put into cache, because students were asking, well, why this, why that? That's obviously important. Very interesting how direct mapped cache, very clever the way that it's sort of strided, the way that blocks get read into cache. So that's, again, for my own purposes, I do think about this sort of thing a lot from optimizing my own code. For me, of course, it's often a plasma physics code where we have some grid in space, and maybe I'll talk about this more in a bit. Maybe you have a grid in space and you need to you care about what's next to any given point. So, in that case, it works well with the cache because you're loading, by definition, you're loading in and you're probably prefetching a lot of the kind of physical space. You obviously have very good spatial locality there in a simulation. If you have some region of space affecting obviously neighboring regions of space, works great with caching. But then when you have 3D, it gets maybe a little bit more difficult. In 1D it would obviously be great, but in 2 and 3D you now have to get, you of course might have it's now not contiguous, right? You're next to something that's no longer contiguous with you. Anyway, maybe that's something we discuss later. That was a live comment there. Back to this, yeah. So okay, back to the kind of UI of what I'm proposing. I mean, I think I just need to sit down when I get time and to sort of basically code at least this aspect up, where you would have, as I say, you'd be able to open up a little panel. It'll have some nice kind of formatting for documentation that's directly in the code. It would be anchored, so you would be able to anchor it physically. Let's say at the top of the function, you'd anchor a top point and a bottom point, and then as you scroll, if you're scrolling past this anchor region, then the kind of wiki thing comes up. You can then drag this very easily. I had feedback that this might be kind of from UX a little bit annoying, but I don't think so. I think you just open stuff out and you just drag it to basically where you want to anchor it. I don't think this should be a problem, basically. So actually a very good comment here. Again, I'm not kind of committing to a particular UI at this stage, right? I'm just proposing things that, as I say, maybe it'll just look nice once I code this up, at least this first point. But yeah, you could have up to 4 different views or 4 different panels. I mean, it would get quite busy simultaneously, but maybe you can switch between different panels where you have the actual proper, OOP or whatever the code may be, high-level code. You have this transpiled business, so you're looking and almost in real time, maybe not necessarily in real time, but almost in real time, you're seeing what happens at let's say, intermediate representation level. You can also see the assembly level, maybe, again, almost in real time. And you'd have something like this where you have this high level description. So up to 4 different windows, as it were, and you can obviously customize it. I'm sure the UX people can figure this out. So yeah, those are comments. So for some people, at least, that would be useful. I don't know. I would personally find it useful. I would like to have certainly, some little wiki that, or some little, article, and probably LaTeX for me, but some little article for how this, particular function works. Oh, did I not have something? Okay. Yeah, that might be it. So point 2, just to expand on this. So as I say, what we're talking about here is we would have, again, building up on the previous point, we would have now a totally optional. You're not locked into this. You don't ever have to see this necessarily, but you have the option to clicking a little button here, and it would show up. Perhaps it's assembly. Again, you get to decide whether it's IR. There's issues. People have said, well, maybe IR is difficult to read. Again, I don't use it very much, but that's something I'd like to kind of use. It would, again, be useful for me. But seeing it directly would probably, and again, that's obviously, there's a comment later that's basically what LLVM is, fine. But the other thing, again, thank you to Alex for emailing this in. I was just thinking the other thing that would be super useful is to have kind of micro benchmarks / micro kind of unit tests that you write directly in maybe this right panel. So here, you basically say, look, time, what this function is, run it 1,000 times with maybe these inputs, right? Here's a, randomly generate a vector of 1,000 floats here and run this, let's say this inverse square root function. And that's integrated into the IDE. Of course, you can do this, but how much faster would it be if you could just almost at the touch of a button have it within your IDE as you're coding? You just boop and you get the response. And again, this is then saved. The micro benchmarks you write are then kind of the way their placement, their anchoring, as it were, is then saved by the IDE. I think that would be useful. This is actually another, I mean, I guess I've said this already, but the point then is this would be useful for me, because I generally do need to write performer code. But if we solve this for people that need it, then the people that don't have time normally, or the projects that don't have enough funding to fully optimize it, if we make it easier for people to optimize, guess what? They'll be able to go back and do it. So then it won't be a trade-off between getting your code out on time and getting it optimized. Now you could do both if you help this. And as I say, some of this stuff already exists, but seemingly, and again, now that I've had feedback, seemingly some of this stuff is not widespread or is not easy, is not kind of done necessarily. So just my ideas here. So yeah, there is a big concern though that basically you'd be locked into an IDE. Now I did try and kind of make this point you can forget my original scheme that I proposed, but I did try and make it kind of put forward a standard rather than a specific IDE. So in principle, in principle, lots of people could either make an IDE that does this, or so something like this, something like having this wiki thing. There should be some way that that you can kind of integrate it without the IDE. There should be some way. Maybe it's by comments. Maybe the way you anchor this physically is with some kind of pseudo comments. I don't know. Or some metadata, but again, it should be accessible. That's what this comment is saying. It would be dangerous to lock you into a specific IDE. That's why I tried to get this idea across, that it should be more a standard than this one kind of program that will let you do it. but certainly a concern. Fair enough. Thanks for the comment again. Yeah. Yeah, good points here. Okay, and then yes, LLVM. Again, I don't think what I'm saying is exactly 100% overlap. There is certainly commonalities. Yes, I also looked at that, but I don't think that this is like a one-to-one mapping, that I'm just reinventing the wheel here. I think, I do think there's something original here. Okay, talking about the there's another thing I wanted to say. So another point about this would be the kind of educational component, as well as simply optimizing code or whatever. Having an educational aspect to this would be good, so people could see the effects of the code they have. Of course, again, you can use other tools for this, but it would be cool to have it in the IDE directly, and it would help to sort of help with the kind of big philosophy that I try to push forward, which is that to have this meta level, don't just have the compiler implement things, have a kind of meta level that helps you manage how you do things, rather than have the programming language itself enforce everything. You could have this sort of meta level for helping users actually manage things. Okay, that's fine. Maybe what I'm saying is just LLVM, but I think there is extra there. But thank you for the comment. And yes, the point here was so to clarify what I'm talking about here in the point 3 that I made, which is that the programmer can now possibly alter the low-level stuff without altering the higher-level code. That would be enforced by a strict standard that would have to be worked out beforehand. In some places this already is done. Maybe you do this just via flags for the compiler. And the answer to comments like this, why just transpile instead of making a better compiler? Because what I just said, because this would let the programmer now get involved. So yes, you could theoretically just have a single pass or multi-pass, but you just hand this over to the compiler, and it gives you your machine code. But here you can get the programmer involved in this kind of optimization level. So more comments on this. Pointing out that maybe this is about it. I'm fully prepared to be proved wrong. This comment is saying that maybe the programmer should not be touched. There's no reason for the programmer to touch the transpiled code. Fair enough, maybe. And then instead, this comment is saying you should only provide compiler arguments and do this via compiler flags. Perfectly fair enough. Maybe that's the way that you should go. But again, you should be able to probably see the effects of those flags just to inspect them, just for, again, educational purposes and that sort of thing. Array of structs versus struct of arrays. Talked about that. But this person says that, it would be nice to see maybe live transpilation. So some merits, some things people would agree with, some things they wouldn't. Okay, the next point is that, or a couple of points here. So someone's saying that if you allow a user to code low-level stuff, that now means that there's basically twice as many bugs, right? There'll be a bug in the OOP code, and there'll be a bug in the lower-level procedural code. But my point was that you can't do anything at the lower level that would... so in one of the schemes, you can't do anything at the lower level that would change the higher-level meaning, so you wouldn't need to debug it, right, by definition, and that's imposed by a standard. if you did make changes to the if the low-level optimization did cause changes to the high-level code, then it would, it would change the higher-level code then, right? So you would just be still debugging the OOP code. You would not be debugging the procedural code underneath. So, and a point here that I think I just addressed, that the idea was, at least my idea was, to get the programmer somehow involved. So it's not just that, oh, you just flip a compiler flag, though that might be how you do it. You might functionally be flipping a compiler flag, but you as the programmer are now getting involved in the business of exactly what's happening at the lower level. Okay. So some people did, some people didn't, but some people did respond well to this idea that you should move some aspects up from just the language, from having, a strict language, up into a more higher level, have some of the more organizational concerns moved up. Maybe that's a good idea, maybe it's not. Fine. Okay. Getting to the end of it, it's been up. Okay, the stream's been up over an hour. Fine. So this was a funny comment. With my sort of nerd cred suitably bruised, I was talking to this commenter, and this commenter was convinced that clearly I have no idea about compiler flags and optimizations, and I was trying to prove that that I actually do know and have been using, and actually been playing around, tweaking different compiler flags for quite some time. Now, and so what I ended up doing was sharing a study I did a while ago about optimization. Now, just to say, I write performant code quite often for simulations, big high performance simulations, but I don't often publish the code itself. So the last time I fully published a code and published a kind of code paper was 8 years ago now, in 2016, and I've actually just had a code paper accepted. So I'm publishing a code, high performance code, to do some physics studies. I'm publishing the code itself. It's already on my GitHub, but I'm it's a peer-reviewed paper about what the code can do. Maybe I'll end this poll and start a new one. So the last time I published a code to do physics was about 8 years ago, and my question is, would anyone actually be interested in just me going over some of that? Let me make another YouTube poll here. Okay, and I will need to be, hang on. Okay, so we will do this in suitable programming fashion. But let me explain what these numbers mean. I'm going to start a poll here. Don't press anything yet. So let's do this. So you can do 2 bits there of the poll contains 2 bits of data. The rightmost bit is a 1 for if you wish to hear me discuss the paper that's already published, possibly at the end of this, although maybe I'll just do a separate live stream. And the leftmost bit set to 1 if you'd be interested in me discussing an upcoming paper. So either do a bitwise AND of these. Maybe I just put a 0 here. So either do a bitwise AND if you want neither, or a bitwise OR if you want both, I suppose. That's the latest poll. So if you want to hear me actually discuss a paper, to kind of, mostly I'm saying this to try and repair my my kind of nerd cred, as it were. If you'd be interested, and so the one I linked to this fella is the one I did 8 years ago was me doing some plasma physics and doing it on a GPU. So I was comparing a CPU code that I wrote and then moving it to the GPU. The one just now, it's just a CPU code at the moment, high performance, kind of, you know, a CPU parallelized. I actually am looking for I think it'd be a great project for a student to then also port that to a GPU or multiple GPUs. Just haven't had time to do that yet. So, and as I say, that second one has just been accepted. I'm just getting the paper kind of formatted before it goes out. So if there's, you know, maybe that's what I do. Maybe I do live stream and we can talk about the physics, but we can also talk about the kind of programming aspects. Yeah, maybe that's what that poll is. Would anyone like me seeing me discuss my physics simulation? But quite rightly, as this person points out, you know, yes, I personally am. You know, that's kind of what I do, and it's obviously more weighted towards performance rather than real world problems. Though, as I said, we have discussed real world commercial problems where performance is important. But yeah, me personally, I often have problems where you do just have simple arrays, and then it's fairly simple to just have a struct of arrays. You know, you might have an array for your magnetic field and your array for your velocity, let's say, right? So you then you would probably then have it a struct of arrays rather than an array of structs. Maybe it makes sense to flip it. That's though a lot easier again for a kind of physics code, because that's just, you know, all your data types are probably going to be just double precision floats as opposed to you know, various things. You probably almost never have strings other than just to kind of label your files or whatever. So actually, you know, there are places where you can have 1 million ints here and 1 million unsigned chars there. I appreciate that may not be in most kind of production commercial software. Yeah. So anyway, there's a poll. If you want me, maybe I should just do some live streams of some physics codes and discuss it both from a physics and a code perspective. Okay. This next, it's a pair of comments by the same commenter, and I had to keep this in because the top one, that is a fantastic put down, and I totally take that on board. It says, designing and implementing performance and size optimized code as an art form. I'm afraid you are not that artist. What a great put down. Thank you. Totally accept that. Fair enough. I'm going to keep that for personal use. I'm going to tell someone, you know, so-and-so is an art form and you are not that artist. What a fantastic diss, as it were. Now, the problem was, so these were both by the same person, kind of in short succession. This top one actually got, as a comment on YouTube, got deleted, or, well, it did get deleted because I could only see it in the kind of little notifications view. That's why I've kind of taken this top screenshot is that notification that someone has replied, whereas the bottom one appeared then afterwards as an actual full comment. I don't know if the user went back and deleted this, which is a great shame. That was a great comment. Or maybe sometimes YouTube deleted. I almost never delete any comments. You can call me, you can say your mama jokes, you can call me whatever. I won't typically delete comments. and I don't like to delete videos. I only just have the concern that I don't want anyone getting the wrong factual information. The bottom comment, though, I don't kind of agree with. So the bottom comment says that space and performance optimization of anything, be it hardware or software, is a top 0.5% skill or less. And in 35 years, I can count on two hands the number of people I've met who can really do it. Now, so implying, I suppose, that that it's hard to optimize, but implying that you shouldn't bother. I'm not sure what the kind of actual point here is, but I would kind of disagree with this. So suppose, for anything, right? You could play this game for anything. You could line up every single coder in the world, and you could line them up in a big long line and order them by their, let's say, skill at optimization, okay? And then you could arbitrarily say that the top 0.5% of them are, over this threshold of being able to optimize hardware or software. Fair enough. To someone's liking. Okay, but you could play the same game. You could say, actually, to really, really optimize stuff, you can be in the top 0.1%. But the point is that, everyone could improve could optimize their code somewhat. Even if you're, not good at optimization, you can still get better. So I don't see the point here. I think it is worthwhile to study how to optimize code, whether you're really good at it or whether you're not, because whatever code you put up will be somewhat optimized. So yeah, I don't. I included this because of the fantastic put down, which I totally accept, but I don't agree that only the top 5% of people should even bother trying. Everyone should try if they have the time, if there's a need for it, if it's kind of worthwhile to optimize their code. Couple more points here. I think these are mostly positive. So the top comment is saying that it's about starting a conversation. On the video I made, yes, factual mistakes, but I did start a conversation. I was very happy with it. I certainly learned a lot, so thank you for the commenters. So positive stuff here in the top one. The bottom one also was fairly positive, so some comments were fairly positive, some were not. And I think that's it. I think that's all the slides I had, and I think that's me answering most of the chat. So that I'll end the second poll. So the two polls were: don't change the original video title. 1, okay, fair enough. I will respect the decision of that vote. And people have 100%, although small sample size, voted for 1.1, which is the bitwise OR of me discussing my previous paper and my upcoming, about to come out paper about performant code, how the code is performant. Okay, I'll have to set up maybe live streams. Maybe that's how we do it. I have been meaning to get guests on. That's what I'd really like, is to just get guests on and live stream and talk about science and maybe coding. So we can try that. Maybe I will get, for the paper that's about to come out, then what I'll do is I will get one of my co-authors, and we'll talk about the science and the coding. Okay. Yeah, I think that's it. That's been an hour and a half. I think that's a good time. So I will thank you for watching, and I will try and set up some more live streams. So thanks. I will see you in the next video.